As we begin with the topic of determinants, let us first see the definition of a determinant. A determinant is a square array of elements arranged in n rows and n columns enclosed within two vertical lines. So it's basically a square arrangement. Therefore, we have the number of rows and columns equal. Now, as an example here, we have two determinants. The first one on the left is a 2 by 2 determinant because it has 2 rows and 2 columns, whereas the other one is a 3 by 3 determinant. Now by the elements of a determinant we mean they can be either pure numbers or they can be even variables and so on. Now here in a determinant, the elements which come in the slant line as shown here, that is from top left to bottom right, these constitute what is called as the diagonal of the determinant. So each determinant will have one diagonal and these are called as the diagonal elements. So let us move ahead and see some of the further terminologies related with the determinant. Alright, now a determinant is denoted by typically either a delta symbol or just uppercase D. So if there are more than one determinant, then we may denote them as either delta 1, delta 2, delta 3 and so on. Next, the line containing elements from top left through bottom right is called the diagonal of the determinant, as we have seen just now. The next one is the general notation to denote elements of a determinant. Now here is how we denote the elements of the determinant. As an example of 3 by 3 determinant, we have the elements in the first row as A11, A12, A13. In the next row we have A21, A22, A23, and in the last row we have A31, A32, A33. So therefore in general the element Aij as shown here refers to the element which comes in the ith row and the jth column. So I stands for the row number and j stands for the column number. Let's move ahead and see how to evaluate a 2 by 2 determinant. So it's important to note here that a determinant has a value, and we will see now the way to evaluate a 2 by 2 determinant. Now as we can see here, if we consider a determinant of say 4 elements, that is A, B, C, D as shown here, then its value is given by the multiplication of A and D, that is the diagonal elements, minus the multiplication of the non-diagonal elements, that is B and C. So this is a way to evaluate any 2 by 2 determinant. Now let us see how to evaluate a 3 by 3 determinant. A determinant can be evaluated along any row or any column. So as an example, let us see how we can evaluate it along say first row. So when we say that we have to evaluate the determinant along first row, say this is an determinant A, B, C, D, E, F, G, H, I. Now what do we do is, we first consider the first element in the first row, which is A. Now if we temporarily remove the row and the column in which that element exists, then whatever 4 elements remain, their determinant is multiplied with the element A. So this is where we get the first term, that is A multiplied by the smaller determinant of E, F, H, I. So this is the first term in the evaluation. After that, what do we do is we consider the next element in the first row, which is nothing but B. So now if we consider B, and if we mentally remove the row and column in which that is present, then now we are left with the 4 elements, that is D, F, G, I. But Now the second term is not added but it is subtracted, so that is, it is important to see that it is a subtraction, that is a minus sign here. So it is minus b into the determinant of dfgi. And lastly, when we go to the third element of the first row, which is nothing but c, so once again removing the row and column in which c exists, the remaining 4 elements are d, e, g, h, and here the last term is once again positive, so therefore we add c multiplied with the determinant of d, e, g and h. So that is how we evaluate a determinant along first row. So we will see later that it's not necessary that the determinant is to be evaluated only along the first row, but we can evaluate it along any other row or any other column, as we will see that later. Now let's move ahead and practice evaluating one determinant as shown here. So as we have seen earlier, let us evaluate along the first row, that is 2 multiplied with, as we remove the row and column of that, we will be left with the smaller determinant of minus 1, 2, minus 2, 1. Then next we have minus sign, and we go to the next element in the first row, which is 3. Now its corresponding smaller determinant is 0, 2, 4, 1. And lastly we have third element as it is, which is already minus, therefore we write minus 1 into its smaller determinant is 0, minus 1, 4, minus 2. Now moving further, we have already seen how to multiply, or rather how to evaluate a 2 by 2 determinant. So first the product of diagonal elements gives us minus 1 into 1, which is minus 1. And from that we have to subtract the product of the other two elements, which is minus 2 into 2, which is minus 4. So since we have to subtract it, it will become plus 4. Next, similarly we have minus 3. Now the first product 0 into 1 is 0, therefore we have 0 minus the other product is 4 into 2, that is 8, minus into bracket, similarly 0 into minus 2 is 0, and 4 into minus 1 is minus 4, but since it's to be subtracted it will become plus 4. So this gives us 4 minus 1 is 3, that multiplied by 2 is 6, minus 3 into minus 8 is plus 24, and finally minus 4. So that gives us 26 as the final answer.